Hello and welcome to this Dr. Ross Maths video on Key Stage 5 straight line equations. Now this is mostly going to be a recap of what you did at GCSE, and if you want to see in-depth stuff about kind of calculating gradient from 2 points, etc., then I recommend that you watch those videos first. I should also point out that in a separate video we're going to be covering parallel and perpendicular lines. So this is just a summary of all the questions we're about to do. We'll quickly recap how to find the gradient given 2 points or given an equation of a line. We're going to introduce a new equation that you might not have seen before about how we can find the equation of a line given 2 points. We'll see how to find the point of intersection of two lines. We'll see how to find the distances between points. And we'll also see how we can use straight line equations for modelling problems. Let's just recap some of the basics about straight line equations. The general equation of a straight line is y is equal to mx plus c. So you may remember that the m is the gradient of the line, and I'll explain what I mean by the gradient in a second, and the c is the y-intercept. So to illustrate what these concepts mean, if I was to draw a particular straight line, let's just say I had y is equal to 2x plus 1, then the y-intercept, this 1 here, is going to be where that line cuts the y-axis, hence the y-intercept. And what that gradient of 2 means is that each time x increases by 1, the y value increases by 2. So the gradient means what does y change by each time x goes up by 1. So we can sort of see that the higher the gradient, the steeper the line is going to be, because the more it will go up each time you go across 1. I should also point out the connection between this equation and the line. This equation is basically a membership rule, and it's a membership rule which dictates whether a point belongs on this line or not. So for example, if I had the point, say 3, 7, then that would be on the line because it obeys this rule, because when we do 2 times the x value, 2 times 3 plus a 1 is equal to 7 equals 7, the y value. So this coordinate does obey the rule. And that's true in general for any line, not just straight line equations, that a line just consists of points that obeys its respective equation. Now let's see a few ways that we determine the gradient of a line. Determine the gradient of the line that goes through the points 3, 5 and 7 minus 3. Now in my previous video on gradient, we saw that the gradient m of a line is equal to the change in y over the change in x. That's the Greek letter delta, by the way, or more specifically capital delta, and that just means change in. Now let's look from this point to this point. What is the change in y from here to here? Well, to get from 5 to minus 3, it's decreasing by 8, so the change in y is minus 8. And then what's the change in x? Well, to get from 3 to 7, that's a change in 4. And minus 8 divided by 4 is minus 2, so it's a negative gradient. And by the way, it wouldn't matter if you went from this point to this point, as long as you're consistent. So if you're changing y from here to here, then you need to do the change in x from here to here and not the other way around. What about question 2? Determine the gradient and y-intercept of the line with equation 4x minus 3y plus 5 is equal to 0. So not all straight line equations are in the form y equals mx plus c. It might be in some other form as well. And if it is in some other form, then we just need to rearrange it so it is in this form, because then we can easily read off the gradient and the y-intercept. And notice here that the y is the subject of y equals mx plus c. So here we just need to make y the subject of this equation. Now a lot of people would subtract the 4x and the 5 to leave the minus 3y, but I tend to like to put the y on the side that makes it positive. So I want to move this minus 3y to the other side, so I'm just going to add 3y to both sides to try and make y the subject. And then to make y the subject, I can just divide both sides of the equation by 3. Now you could put the whole thing over 3, but it doesn't put it in this form. I would divide each individual term by 3. So 4 divided by 3 is 4/3 x. And then that 5 divided by 3 is 5 over 3. So I'm dividing each individual term by 3. And now we've got it in the form y equals mx plus c. Y equals mx plus c. So we can see therefore that the gradient is equal to the 4/3, the number in front of the x, and the y-intercept is just 5 over 3. What about question 3? Find the equation of the line that goes through a and b, giving our answer in the form ax plus by plus c equals 0, where a, b and c are integers. And I should probably identify what the different forms of straight line equations are called. When I have y equals mx plus c, that's known as slope-intercept form. Slope here is just another word for gradient. But when we put it in the form ax plus by either equals c or plus c equals 0, that is known as standard form. And I'm not going to go through why that's important in this video, but I do cover why this particular form of a straight line equation is helpful in practice. So we want to get it in this form for these particular points here. So let's just imagine our line going through 4, 5 and 6, 2. Well, we need two things to find the equation of a straight line. We need some point on the line, and we also need the gradient of the line. So let's always find the gradient first. The gradient of this line is just going to be change in y over change in x, just like we used before. Now, if we go from this point to this point, the change in y is 5 to 2 is minus 3. And the change in x to get from 4 to 6 is 2. So our gradient is minus 3 over 2. Now, there's two ways of then finding the equation of this line. The way you might be used to from pre-A-level, if you're doing A-level now, is this, that we start with y equals mx plus c. And then because we know that the gradient of this line is minus 3 over 2, we can sub that in. So we've got y equals minus 3 over 2x plus c. And then we can just pick one of these points because we know that I of these points has to satisfy this equation because it's on the line. So if we just say choose the 4, 5, then let's sub it in. The y is the 5. And then we've got minus 3 over 2 times 4 plus c. And now we can just simplify that. So minus 3 over 2 times 4 is minus 6 plus c. Minus 6 plus what is 5? What's 11? C is 11. And therefore, if we just put that back in, we've got y is equal to minus 3 over 2 x plus 11. And then we can manipulate that to put it in this particular form. So that's a sort of like pre-A-level way. But the way we're going to do it is to use a new formula, and it's this. If you have a line that goes through a particular point, and let's call that fixed point x1, y1. So this is some specified point, and we have a particular gradient. Then there's a formula that gives you the equation of the line directly, and it's this. Y minus y1 equals m brackets x minus x1. Now, I'm not going to prove in this video, but I do so in my slides. But this is a key formula. So if we use that using one of these particular points, we'll choose this one again, and using that gradient, let's just sub it in. So we've got y is still a variable, minus y1, so the y1 here is the 5, it's this fixed point here, is equal to m, which we worked out was minus 3 over 2, and then x is still a variable, minus x1, that's the particular x at this fixed point here, the x1, y1, so that's 4. And then we can just manipulate this in order to get this form here. We just want integers in here, so we don't want this over 2, so we're going to multiply both sides of the equation by 2. So 2y minus 10 is minus 3 brackets x minus 4. A common student error, by the way, is to times that by 2 and that by 2. But if you times both these things by 2, you end up multiplying it by 4, not by 2. So then let's just expand out the bracket. And then finally, we put it all on one side. I tend to make the x term the positive one. I like the first term being positive. So I'm going to move it all to the left side so x is positive. We've got 3x plus 2y. And then we've got the minus 10 minus that 12 minus 22 is equal to 0. And I highly encourage you from now on to get the equation of our line using this particular formula here and not using the GCSE method, if you like. Now this second one, you'll see the advantage of the second method because we're going to get awkward fractions here. We've got 2 points, minus 1, 9, and 4, 5. And again, we want the equation of the straight line that goes through these 2 points. So let's find the gradient again. M is just equal to change in y over change in x. Let's go from this point to this point. The change in y from 9 to 5 is -4. Be careful about the sign. It's decreasing by 4, not increasing by 4. And to get from -1 to 4 for the x change, it's 5. So we've got -4/5. And again, we're going to use this formula, y minus y1 equals m brackets x minus x1. So again, we choose one of these 2 points to be our fixed point, x1, y1. So let's just use this first point. So that's your x1, that's your y1, and that's your gradient here. So let's just sub in our stuff. We've got y minus y1, the y1 here is 9, is equal to m minus 4/5 x minus x1. So we've got x minus minus 1, x plus 1 there. And again, we want in the form ax plus by plus c equals 0, only using integers. So we don't like that over 5. We're going to times everything by 5. Then we're going to expand out the bracket. And then we're going to put it all on the side where x is positive. So let's put on the left-hand side. We have 4x plus 5y. Then we've got the -45 plus the 4 is -41 equals 0. Right, question 4. The two lines intersect at P, so you've got y equals 3x, x plus 2y equals 4. They intersect at this particular point, and this line here, the x plus 2y equals 4, crosses the x-axis at the point Q. Determine the coordinates of P and of Q. So we need to find where these two lines intersect. Now, as you've seen before, when we want to find where two lines intersect, we just simultaneously solve the equations. Because remember, this line here are all points which satisfy this equation. This line here consists of all points which satisfy that equation. So therefore, if this point is on both lines, it must satisfy both equations. So we just need to solve them simultaneously. So we've got y equals 3x, and we've got x plus 2y equals 4. Now there's lots of different ways of solving simultaneous equations, but the easiest way here is just to use substitution. If y is equal to 3x, then we can substitute that into this equation. So we get x plus 2 times y, where y is 3x, so 2 times 3x equals 4. So that means x plus 6x equals 4, 7x equals 4, and that means x is 4/7. And then we can substitute that 4/7 into either equation, doesn't matter which one, but this equation is easier, y is 3x. So y is 3 times 4/7, 3 times 4/7 is 12/7. So we've worked out where these lines intersect. The point P is going to be 4/7, 12/7. And we also want to find the point Q, where this line here intersects the x-axis. Well, when we're intersecting the x-axis, the y value is 0. So if we just make y equal to 0 into x plus 2y equals 4, then that just gives us x plus 0 equals 4. So we get x is 4, and that means the point Q is equal to 4, 0. And then it says, hence determine the area of OPQ. So OPQ is this triangle here. So if I just quickly copy that diagram out, I've worked out that this coordinate here is 4/7, 12/7, and I've worked out that this x value here from over here is 4. Now we know how to find the area of a triangle. It's just half times base times height. And basically with these coordinate geometry questions, when you're asked to find the area of the triangle, usually you can make the base either the horizontal or the vertical. So in this particular case, I should make the base the horizontal because I can clearly see that that base is of length 4. And then I can easily get the height because this height here, the triangle, is just a y value, isn't it? So the height is 12/7, and then that means the area is just half times the base of 4 times the height of 12/7. So that will just be 24/7 units squared. And we'll see another question like that later. Well, I first want to see how we can find the distance between 2 points. So let's just give you an example first. Let's say I had the point 5, 3, and let's say I also had the point 8, 7. And we want to find this distance between these 2 points. Well, we can actually use Pythagoras to do this. So if we were to draw a right angled triangle with a horizontal line and a vertical line, what is this distance here? Well, this distance here is basically the change in the x value. So if we're going from 5 to an x value of 8, we can see that that distance is 3. And if we have a y value here of 3 and a y value here of 7, that distance must be 4. And then basically this length we can get using Pythagoras. So if we just do the square root of 3 squared plus 4 squared, we can see that that distance, if we put it on a calculator, is 5. So more generally, the distance between 2 points is equal to the square root of the change in x squared plus the change in y squared. And that is a key formula. So let's use that formula on these two problems here. We've got 3, 4 and 5, 7. Well, the distance between those 2 points is just the square root of the change in x squared. Well, the change in x from 3 to 5 is 2, so we've got 2 squared, plus, and the change in y from 4 to 7 is 3. So we do 3 squared, and if we put that into our calculator, we get the square root of 13. And you could always give that as a decimal if it asks for it. And what about b? We've got this time 0 minus 2 and minus 1, 3. So the distance between those 2 points is just the square root of the change in x. Well, the change from 0 to minus 1 is minus 1. But to be honest, because we're going to be squaring it, we can just quote the difference as a positive value. So the change here is 1. We don't care about the sign. And the change from minus 2 to 3, well, that's going up by 5. So it's 5 squared. And that gives you the square root of 26. Let's go to question 6, which is similar to question 4 we had earlier. Determine the length of PQ. So we need to work out what these 2 points are first. Now the point P is just the intersection of these 2 lines. So we've got 2y equals x plus 4, and we've got x plus y is equal to 8. Now there's different ways of solving this. We could either use substitution or we could use elimination. So I'm going to use elimination. If I just rewrite this equation here as x, and then we're going to subtract the 2y, and then move the 4 over here instead, can we see that we have 2 equations in the form something x plus something y equals something. And then we can just use our simultaneous equation solver on our calculator, and you're absolutely allowed to do that if it's an A-level exam. So we got 1, 1, 8, and 1 minus 2 minus 4. There's your coefficients. And that gives you x is 4 and y is 4. So let's try and build up this information on here. We've got this point here, P, is equal to 4, 4. And we also need to find Q and R. Well, Q is just the y-intercept of this line here. And to find the y-intercept, we just make x 0. So in the 2y equals x plus 4, if you just make x 0, we get 2y is equal to 4. And that means y is 2. So this y value here is 2. And then we also probably want r, because that's going to help us at the end. That's the y-intercept of x plus y equals 8. So if we just do it in our heads, we notice that x is 0 here. So if we have 0, we sub it in, plus y equals 8, then the y value must be equal to 8. So we want to find the length of PQ. So PQ, that's P, and that's Q here. So we can just use our usual formula. So the length of PQ is equal to the square root of the change in x squared. The change from 0 to 4 is 4. And the change from 2 to 4 is 2. And that gives us the square root of 20, which we could always simplify. And then, again, we want the area of PQR. So it's this area here. Now this time, it makes more sense to make the vertical the base, because none of these 3 edges are horizontal, but we do have the vertical. So we're going to make that the base, and that is going to give you an area of half times the base, where we can see this distance here, the base, well, the distance between 2 and 8 is 6, so we got 6, times by the height of the triangle, which is this distance here, and we can see that's just the x value of this point here, which is 4. So that gives us an area of 12 units squared. And then finally, question 7, we've got this nice modelling question, and particularly in the new UK A-level, they do like modelling questions indeed. The population of Bickerstonia in the year 2002 is 750, and in 2008 is 1,950. I decide to use a linear model for the population P in terms of number of years T after 2000. Determine P in terms of T for this data. Well, if we were to plot the population P against the time T, then let's use the data points we're given. We're given that in 2002 the population is 750. So t is the number of years after 2000, so t is 2 here. So we've got 2 as the t value, p is 750, so 2, 750. And then when it's 2008, so when t is 8, the population p is 1950. So we've got 8, 1950. And it wants us to find an equation for a straight line because we're using a linear model, so that means that we want to represent the population as a straight line equation. So we need to determine p in terms of t. Well, let's find the gradient first. Well, the gradient is equal to change in y over the change in x. Well, the change in y to get from 750 to 1950, if you subtract those, you get 1200. And the change in x from 2 to 8 is 6. And then 1200 divided by 6 is 200. So that's the gradient. And then to find the y-intercept, there's lots of ways of doing it, but let's just use the y minus y1. So we've got y minus y1 equals m brackets x minus x1. I know I'm using the wrong variable names here, but I'll fix that in a second. So we've got y minus of y1. We're going to use this as our fixed point in this case. So the y1 is 750 is equal to the m, 200, x minus x1, which is 2 here. Let's just expand out and simplify. And we do want to make y the subject here. So y is 200x plus 350. But I've used the wrong variable names. So y is actually p here. And x is actually t. So there we go. We've got our linear model, our straight line equation. And then estimate the population in 2020. Well, that's when t is 20. So we can just use our linear model now to make that estimate. So when t is equal to 20, we get p is equal to 200 times 20 plus 350. And that's going to be 4,350 people. And finally, explain a possible limitation of this model. And I think the main one basically is that populations don't tend to grow linearly. They don't tend to grow as a straight line. Population tends to be exponential, i.e. you have a kind of percentage increase each year rather than a fixed increase in terms of the number of people that you gain or lose each year.